Hello everyone and good evening. Welcome to the OneClass channel. My name is Fajuri Rome and I'm an honors Bachelor of Science graduate and currently working towards medical school. For today we'll be going over some commonly asked chemistry questions at both the high school and college levels. If you need some homework help or some extra help with tutoring, check out the links in the description below. With that being said, we're going to kick it off with this session. Give me a quick second to set that up here. We're going to have starting here, and we are good to go with question number 1. We have decide whether each molecule or polyatomic ion is polar or nonpolar. So for the first question, decide whether each molecule is polyatomic, or each molecule or polyatomic ion is polar / non-polar. Okay, so with this it looks like the student had already gone through the question, but just so we review this to understand what it means to be polar and non-polar, it helps to be able to draw the Lewis dot diagram. Okay, so with that being said, they give an example of what they're looking for. So if it's polar, you want to write the chemical symbol of the atom close to a negative side. So HCl, for example, in the example give, they have HCl. This is a polar ion, okay? Because chlorine is where the negative is going to be. Okay, it's going to be, well, it's going to be the pseudo-negative part, okay? And hydrogen is going to be more positive. And this is based on the electronegativity difference. But with that being said, the reason why they say you enter hydrogen is because chlorine is your quote-unquote negative side. So the atom closest to that negative side is going to be here, because chlorine cannot be close to itself. It is itself. So that's why they say you use hydrogen there. So with that being said, let's go through this question to see whether it's a molecule or a polyatomic ion. So we're going to start with CH3F, okay? So we're going to put a carbon in the middle, okay? And this is what CH3F looks like. You can even check this by making sure you have the right amount of electrons. So carbon would be able to donate 4. There's 3 hydrogens, so that's 4 plus 3. And fluoride has, fluorine has 7 electrons. So 7 plus 4 plus 3. In total, we do have 14. So our Lewis body diagram should also have 14 electrons. And we can check, we have 8 surrounding the fluorine, and then plus 6 more. So indeed, this is going to be our Lewis dot diagram. So now we see, based on the, if we look at the periodic table again, fluorine is actually one of the most electronegative elements, actually. So it has a whole electronegativity of 3.98, while carbon is 2.55. We can't do the math, but we can see just by visual that it's going to be greater than 0.3. And the reason why it needs to be greater than greater than 0.3 difference is because this is what defines it as a polar bond, okay? Polar bond. And this is important because if fluorine is the only one here, there's nothing that really counteracts it. The hydrogens actually have a much less electronegativity as well. It's just 2.20. So that being said, the greater the electronegativity, the greater concentration of, I guess, electrons there'll be there. It'll be the more negative end, okay? So for this, we can actually make this the more negative. Now, the second part of the question, it asks, which is the atom close to it. Because of that, it would actually be carbon. Carbon will be the atom closest to the fluorine, because fluorine is a negative. So the atom close to the negative side is the one attached to it, and that would be the carbon, not the hydrogens. So with that being said, for the first box, it'll be, so if we actually just maybe and do that, CH3F, we have the first answer. It is indeed polar, and the atom close to it will actually be carbon. Okay, so now let's move on to the next one, F2. Okay, so this one, when we draw it out, remember that fluorine has 7 electrons, so if we add them together, we're working with 14 electrons total. So Lewis dot diagram for fluorine molecule would just be like this: 1 bond between them, and then following the octet rule. And if you added all the electrons, it should indeed equal 14. Now, as we're saying, because now they're the same molecules, actually in this case, the electronegativity difference will just be 0. So there wouldn't be a positive or negative side based on this molecule. So that being said, because there's no positive and negative side, there's no direction of where it will be attracted to. This would be considered non-polar. Okay, and now which is the atom close to the negative side? It'd be nothing. It does not apply here. In fact, it'd just be better to just put Na. Okay, not applicable. Now for the last one, NH2 minus. Okay, so for this one, let's just do a quick recap. Nitrogen has 5 valence electrons, and each hydrogen has 1 valence electrons. But there is a minus sign, meaning that we have 1 extra electron to work with. So if we have 5 plus the 2 hydrogens, that's 5 plus 2, plus that 1 more electron. In total, we're working with 8 electrons. And if we drew it out, it would look something like this. That would be NH2 minus. Now, as you can see, it fills the octet rule, so we're set there. Okay, and in a sense, what nitrogen would typically look like is like this, because it would have 5 valence electrons, and 2 of the 5 currently are being shared with the hydrogen, which provide 1. So that now that extra electron can just fit right there, allow nitrogen to meet that octet rule. So now with that being said, to make sure that our charge is going to be on the nitrogen, we can actually use formal charges here. So nitrogen, the formal charge, the way you calculate it would be 5 valence electrons minus how many electrons it has by itself, so it's lone pairs, but individually, so that'd be 4 electrons total, plus how many electrons it's sharing. So it's sharing 4 electrons, right? But we have to divide that by 2. So that being said, we have 5 minus 6, which is minus 1. So this nitrogen does indeed have a charge of minus 1 right here. So that would be the most negative side, okay? And you can tell right away, because of the lone pairs, right? These aren't evenly balanced, okay? These lone pairs, well, the nitrogen itself will have its own pull. Looking even at the periodic table, you see nitrogen has an electronegativity of 3.04, and hydrogen is 2.20. So that is still greater than 0.3. So that is a polar bond between the nitrogen and hydrogens. In fact, it's a specific type of polar bond known as hydrogen bonds. But nonetheless, we can still say exactly that it's a polar molecule, okay? And the atom closest to the negative part will be any of these 2 hydrogens here. Because as long as they're touching nitrogen, which is the negative part, the hydrogens are the ones closest to it, okay? So this will be how you approach this question. This is a quick breakdown of what we did. You first have to really understand your Lewis dot diagram, so you can just do quick sketches as what I did. And then you have to know how to identify where your negative side will be. This is done through the electronegativity. Okay, that's very key and important. Even if you weren't sure about the Lewis dot diagram, as long as you can maybe get a, I guess, a picture in your mind of what things connect to each other, you can calculate the electronegativity difference, allowing you to see if it is a polar or a non-polar molecule based on how it can balance out. Okay, and the last part, just the atom close to the negative side. With that, just make sure that you always attribute the negative side to the one that has the greater electronegativity. Okay, and if there's a big enough difference, that's when you say, okay, this is just more negative. All right, so that is how we solved that question. Let's see how we did. Yep, CH3F is polar, And the closest one is a carbon. F2 is nonpolar and not applicable. And NH2 polar and is a hydrogen that's the closest part. So this is correct. Hopefully we were able to break down this question sufficiently. And if you had any parts of pause, you can always just go back and just play it again just to see how we were able to get to this answer. With that being said, let's move on now to question number 2.